This first question, as usual, fairly straightforward. Obviously, you'll need to read the introductory paragraphs, gives a nice little bit of a background, and also there is some very important information in here to help you answer the questions. So, write an equation for the reaction between cellulose and nitric acid to form cellulose trinitrate. So we have the cellulose up here, so we just go ahead, write that down, C6H7OH3O2, and then it says that it reacts with nitric acid, so we add HNO3, and then that is going to form our cellulose trinitrate, given here, C6H7ONO2, 3O2, and then we have one other product. Now, it should be a reasonably easy guess that that other product is going to be water, but by inspection you can see that nothing has really changed here. C6H7, C6H7, my O2 is still the O2. Now my three OHs here have been swapped for three NO3s. So all that's happening is the NO3 here is swapping out for this. So I can just go ahead and balance the equation. So if I've got three OHs here, my three NO3s here, well, the NO3 is going to come from here, so I'm probably going to need a 3 there. And then those three hydrogens, the ones that the NO3 goes in here, the three hydrogens left over are going to go with these to make my water, so I'll get 3H2O. So moving on, we then are asked to draw the dot and cross diagram for the nitronium ion. We are kindly told what the nitronium ion is. It's NO2+. So we would go ahead and put the N in the middle as the least electronegative element. Oops, sorry, let me move that up. The N in the middle as the least electronegative element. And my two oxygens on either side. And then I count up my electrons. Well, N is 5, O is 6, O is 6, gives me 17 minus 1 because of the positive charge will be 16 electrons. Now obviously there are ways now of working out how many bonding electrons, how many non-bonding electrons, but at this point you should just be able to get a bit of a feel for it. So you just start putting electrons in. That's 4, probably going to be some electrons there, that's 6, 8, and then we're probably going to need to have some double bonds, 9, 10, 11, 12, and at this point I've only got 4 left, so it becomes pretty obvious that it's going to have to be that. Alright, and then I do need, because it asks for the dot and cross diagram of the ion, you've got to make sure that you've got the positive charge on there. Now, although the question does say draw a dot and cross diagram, I don't believe that we should be penalised for just drawing dots or crosses. So for me, that is absolutely fine. Then it says, write the equation for the formation of the intermediate from nitric acid and sulfuric acid. And it says here, the nitric acid acts as a Lewis base and accepts a proton from the sulfuric acid to form an intermediate. So that should be fairly straightforward. So we're going to react the nitric acid and the sulfuric acid. And it says that the nitric acid is a Lewis base accepting a proton from here. So we're going to become, and it even tells you in the question that it's going to become H2NO3+, very kind, H2NO3+, and the sulfuric acid has lost a proton, so that will become HSO4-. Okay, so the next part then says, write the equation for the decomposition of the intermediate to form the nitronium ion. So this intermediate here, the H2NO3+, that decomposes to form the nitronium ion, which we were told up here is NO2+. So our H2NO3 decomposes, so it's not going to react with anything, and that's going to give me NO2+, and if I subtract NO2+ from here, clearly I am left over with just one molecule of water. So far, fairly straightforward. Then we have a combustion equation, specifically a complete combustion equation. So our cellulose trinitrate C6H7N3O11, C6H7N3O11 plus oxygen. Now complete combustion, so we're going to get carbon dioxide I'm going to get water, but then obviously I've still got a nitrogen here. So let me check back at the question. It says complete combustion of cellulose trinitrate produces carbon dioxide, got that, water, got that, and a gaseous element. Excellent. So I know because it's a gaseous element, it must be N2. So the requirement now is just to balance it. So we've got 6 carbons here, so that's going to be a 6. I've got 7 hydrogens here. This is the only thing with hydrogen in it, so let's go ahead and put a 7 over 2 there. I've got 3 nitrogens. This is the only thing with nitrogen in it, so I can put a 3 over 2 there. And then all I need to do is balance the oxygens. So here I've got 12. Here I've got 3.5, 1.5. So how many is that? Oh no, wait, what am I doing? Shouldn't be counting that. Let's start again. So here I've got 12. Here I've got 3.5. So that's 15.5. Here I've got 11. So just should be 4.5, 9 over 2. Let's just double check that. That was a bit sketchy. So 11 plus 4.5, that's 15.5. 12 plus 3.5, 15.5. Yes. Okay. I think the current mark scheme, I'm not sure if that's correct in the current mark scheme. Obviously, before you watch any of these videos, you should just check the mark scheme yourself, see if you can work it out yourself. But I'm not sure if the current mark scheme says 9 over 4. So maybe I'll double check that later. But anyway, let's carry on. So calculate the standard enthalpy of combustion of cellulose trinitrate. So we're given enthalpies of formation. This caused a little bit of trouble for some of the students that I spoke to because they were given the erroneous carbon monoxide enthalpy of formation. And I think they then started to get a little bit concerned. Maybe they hadn't done the right equation for this one because they weren't going to need to use it. I think you just need to be confident in what you're doing. So I can just go ahead and start putting these values in. As it's formation data, it's going to be a products minus reactants situation. So I'm just going to go ahead and you'll see it's going to be 6 times my carbon dioxide formation, which is minus 393.5, plus 7 over 2 times my water formation, which is minus 285.8. Nitrogen is an element, so there is no formation for enthalpy of formation for that one, and then I subtract my cellulose trinitrate. I've only got one of those, so it's going to be minus 653.1. So let me go ahead and get my calculator, a little bit of calculation here. So it's going to be 6 times minus 393.5 plus 7 over 2, 3.5 times minus 285.8 is that, and then minus, so plus 653.1 gives me my minus 2708.2 kilojoules per mole. Okay, carry on. So now we go to F. Write the equation for the decomposition process. Assume that all products are gaseous and no oxygen is formed in the reaction. So let's just double check what's happening here. When a shot is fired, complete combustion does not occur. So we've just done the complete combustion here. So it's saying that we do not do complete combustion as there is not enough time for to react with oxygen from the air. Instead, it decomposes to gaseous products. All right, so a little bit tricky, this one. I think this is where people first started to get a little bit, started to have a little bit of a struggle with how this paper was going to go. So we're going to get C6H7N3O11. Now it's decomposing, so there's not going to be any other reactant. Now all of the products are going to be gases, and it doesn't say it's in complete combustion, but it does say it's not complete combustion. So what we can do is we can go ahead and assume that we're going to make carbon monoxide. We're not going to make carbon because it says that all of the products are gaseous. Now carbon is a possible product of incomplete combustion, but not if we're looking at only gases. Then we go with H2O and then N2. Now you can try and balance this equation and you'll find that it is not possible. So there must be another product, and that is going to be our CO2. I can't think of any other way of being 100% sure except for just trying to do that, realising it's not going to work, and then having to do it with the CO2. Now, a little bit trickier to balance. Obviously the nitrogens are still fairly straightforward, 3/2. The water is the only one that's got hydrogen in it, so that's going to be 7/2. Now, how do I balance the carbons and the oxygens? So I've got 11 oxygens to start with, and I've got 3.5 here. So 11 minus 3.5 gives me 7.5 oxygens. So from the carbon monoxide and the carbon dioxide, I need to get 7.5 oxygens and 6 carbons. Now, at this point, you know, you can either sort of, if you're very, very good at maths and you see patterns quite easily, you'll be able to work that out. If not, it's just going to be a case of trial and error. Given that I've worked out that I need 7.5 oxygens, you know that these are not going to be integer values. So it's going to have a half in it somewhere. Now, for me, I kind of think, well, if it's 7.5, but I need 6 carbons altogether, I'm probably going to end up with a lot more of this than of this. And then you can just sort of have a little trial and error. So it can't be 0, it can't be 1, it can't be 2. So could it be a half? A half of that, and then 7 of that. It's not going to be enough. What about 1.5 of that? 1.5 of my oxygens. So 3/2 times 2 is going to be 3, and then that means I'm going to need 4.5 here, and then 1.5 and 4.5. That makes 6 that I need for the carbons. All right, very, very hand wavy, sort of in your head trial and error. This is pretty much, given the nature of the question and the paper, it's, you know, you need to be very quick at that kind of thing. If it's not something you can do very quickly, it's the kind of thing that I would leave to the end and then come back and try and have a go at it, because it's if you're not confident with it, it's the kind of thing you could sort of waste 5, 6, 7 or 8 minutes just sort of bang your head against the wall trying to make the numbers add up. You want to come at it with fresh eyes, a clear head, and have another go at it. So that means we can move on now to the last part. Calculate the total volume of gaseous products formed from the decomposition of 5 grams of cellulose trinitrate. So we're going to have to use this equation. All right. So we know that all of these products are gases. So we need to know how many moles of gas we have. In order to do that, we need to know how many moles of this we have, which means we need to know the molecular mass of that. The molecular mass I'm not going to do here, but you should be able to work out that the molecular mass is 297.15 grams per mole. So then I can work out my moles, which is going to be 5 divided by 297.15. The mark scheme will be more rigorous with me concerning significant figures. This should probably be 5.00. I'm not going to worry too much about that. The examiners do say that they're not overly concerned with significant figures. Significant figures are important, but the people that set the exam are more interested in your ability to do the chemistry. But we will worry about it a little bit later. So if you do that, so if I do 5 divided by 297.15, that gives me 0.0168. Now that's the number of moles of my cellulose trinitrate. Now that's going to be converted into these 4 different gases. So I just need to add these up. So 9 and 7 is 16, and 6 is 22. 22 divided by 2 is 11. So my moles of gas is going to be 0.0168 times 11. So I multiply that by 11, gives me 0.185. And then all I need to do is go and put that into my ideal gas equation. So PV equals nRT. I am trying to work out the volume of gas produced, so it's going to be nRT over P. So that's going to be my moles from here, 0.185, multiplied by my ideal gas constant from the datasheet, 8.314, multiplied by my temperature. My temperature is 200 degrees, so that's going to give me 273 plus 200 is going to be 473, all divided by my pressure. Now, we are not given much information about the pressure, so it says calculate the total volume of gaseous products produced from the decomposition, blah, blah, blah. Nothing about pressure, so let's go ahead and assume we are working at atmospheric pressure, which in pascals is going to be 101.325. Now that will give us our final answer, because we are using the correct units here, that answer should just come out in meters cubed, which is what we're asked for. So if we do it, times it by 8.314, times it by 473, divide by 101,325, gives me 7.18 times 10 to the minus 3. And if I look at my question, I'm looking at 3 significant figures. I mean, this a little ambiguous, maybe it's 1 significant figure, but I think we can safely assume that given that this is 3 significant figures, we're probably talking about 3 significant figures here, and the safest bet is to give your answer in 3 significant figures with the units.